Hello, this is a demonstration of completing a histogram and estimating statistics from it from the MEI syllabus, and I'm S1 syllabus, and I'm going to be using the June 2009 question 3 as an example. Just to start off with by making the point that histograms are not like bar charts in that they are about continuous data. There are no gaps between the bars. It's got a proper scale on the bottom, an axis which goes from a lower number to an upper number, and that's what we are going to be drawing. And we are, in these cases, we are graphing frequency density because we're trying to make the information in front of us comparable, where we've got different classes or different widths of the classes, and we'll go through and have a quick look at that. So that's what makes it different. In this case, we're looking at travellers per mile. So let's have a quick read the question and see where we are. Part 1. The frequency table below shows that distance travelled by 1,200 visitors to a particular tourist destination in the UK. So what have they done for us? They've given us a table here with the distance in miles, D. It's split into classes here, so ranges of distance travelled. So here the distance is between 0 and 50. The next one's between 50 and 100, etc. They've then given us the frequency. That's effectively the number of travellers of these 1,200 travellers. So we can, they total to 1,200 here, don't they? 1,200 travellers and how far they travelled. So in the first column here, we've got 360 travellers travelled between 0 and 50 miles. Okay, so now we've understood the data. What's it asking us to do? Part 1, draw a histogram on graph paper, which presumably will be supplied in the exam, to illustrate these results. So what's the first thing we have to do? Well, we have to calculate the figures to graph. I'm going to do a quick table underneath here, distance, so that you can see what's going on in my thinking as I go through it. So first thing we've got is we know we've got our distances and they're in our ranges. So let's quickly copy those over. In the exam, you might just want to write some of this directly below the table on the sheet to save yourself time, but today I'm going to do it fully so you can see what I'm doing. Okay, what my thinking was. So here's our distances, and they've given us our frequencies. So those are the two givens, aren't they? 360, 400, 307, and 133. Okay, now we're going to calculate some figures. The first thing we need to know is the width of these classes, as they're called. Here the class is in distance. So looking at this first class, it goes between 0 and 50. So the class width is 50. Don't get confused about the fact that it's got a less than or equals on the left-hand side and 50 on the right-hand side. That means this range goes from 0 all the way to 49.999999999. So in effect, it's 50. The only thing that's excluded from it's the 50, and that appears in the next class. It's just a way of drawing the line between the different classes. So the next range is 50 to 100. So again, that range is 50 miles. Going on to the next class, well, that's from 100 to 200, so that's 100 miles. And final class is going from 200 to 400, so that's 200 miles. Now we need to calculate our frequency density, which is our frequency divided by the width. In effect, what we're doing here is we're spreading out the 360 travellers within the 50 miles. So 360 divided by 50 miles is 7.2 travellers per mile. Okay, so I'm going to write that just here so we can see. Effectively, our units are travellers per mile. Okay, so the next part is excuse me, if we got 400 travellers who travelled in this 50-mile bracket, so that's 8 on average, 8.0 travellers per mile. Here we've got 370 in a 100-mile bracket width, so that's 3.07 travellers per mile. And finally we have 133 travellers in 200 miles, so we've now dropped below 1 per mile, so we're down to 0.665 travellers per mile. Okay, so that's the first part of it. We've now created the data that we're going to need to use in our histogram, and I'm now going to just import a piece of graph paper below, and then we'll start filling it in. Okay, here's our piece of graph paper, and first thing we're going to do is we're going to construct our axes. Well, we know we're going to need a height. Our top height is 8, so we're going to need about 10. The best way is to take 10 squares. We do that, so that can be our first, that's 0. It's going to be 1, so it's going to be, how many squares have we got here? Here we go, I'm going to use that, so that's going to be 2, 4, 6, 8, 10 squares. I'm going to do it with those 10. So that's going to be our units. So that's frequency density. I'm going to write it here. It's not going to be as clear as you can write it, but our vertical axis is that. And I would definitely recommend that to make it clear that you've understood it right. What that means in reality, that's travellers per mile. So that's going to be our vertical axis. Then we need a range going on our horizontal axis. We're going all the way up to 400 miles here, aren't we? We're going from 0 to 400 miles. So we've got 50 miles, 100 miles, 150, 200, 300. I'm just going to go on and do that. 400. And what we're looking at here, we're looking at miles travelled. Okay, so now we've got our area mapped out. Let's start filling in. We also need to just add our lines here. Excuse me, I'm not so good here doing it freehand. You would of course use a ruler. Haven't got one to hand here. And let's have a look at our first group of data. So our first one that we're going to draw is the range 0 to 50, and we are going to graph the frequency density, which here is 7.2. So here's our 7, and that will be 7.2, and we're going 0 to 50. You, of course, will be doing it much more accurately than me here. Your next step will be, our next section is 50 to 100, and our frequency density is 8. So that's going to be, there we go, nice. That was a nice and easy one. Our next section is 100 to 200, and our frequency density is 3.0. So here we've got a wider columns going across a wider section. Here we go. And finally, we've got on range 200 to 400, and we're down to 0.665. So 200 to 400, oops. You, of course, will be doing all of this neatly with a ruler. But basically, there's our histogram. Just make sure that everything on your histogram has been labelled. You'll get marks for labelling, frequency, density, miles. You will get marks for having correctly positioned the ends of your bars, of your individual bars here, yeah, your rectangles, and you'll get marks for correctly having set your vertical heights on your bars. So that's really important that you've checked all of that and made sure you've got it right. So if I remember rightly, that's 5 marks for doing what we've just done. Let's check that. Yep, there's 5 marks from the paper for doing that. Now let's have a look at part 2. Calculate an estimate of the median distance. Median distance, why they are distance? Of course, we're dealing in miles here, aren't we? So we're looking for the median distance, the median distance that people have travelled. Okay, well, we've got all the source data here. First question for us is, median distance. Estimate median distance, isn't it? First question for us is, therefore, which is the median or middle traveller? Well, we had 1,200 travellers. So our median traveller will be 600. Middle of those, yeah, 600th. So we can now go through and we need to establish where our 600th is. So just extend so we can see it. Let's have a look back on our histogram. So in our histogram on our frequency table, well, we've got 360 in the first group, and we're looking cumulatively here. So at the end of this group, we're at the 360th, and at the end of the next group, we're at the 760. So 760. Right correctly today, 760th traveller. So it's in this window. It's between 50 and 100. So how are we going to estimate that? Well, we've got 2 methods. Just going to transfer that information that we just had here. Looking at that table, we had between 50 miles and 100 miles. At 50 miles, we had 360 travellers. That's miles at the top, and that's travellers here. That's 760. So if we did it we can see that we need to find where the 600th traveller is from the bottom. So this is one way of doing it, is to look at how far that would take us over the 50 miles, isn't it? So we started at 50 miles, and over this distance we've gone up 400 individual travellers, but actually we only need to get up to the 600th traveller, which would be this distance here. Therefore will be 240 within the group. We had 360 out by the time we got to 50, and now we had 240 more to get to 600. So this is an approximation, as this is on linear here, isn't it? We're doing in effect. So we only need to go up 200 of the 400 travellers, and the distance that we are moving up is 50 miles. So that would give us an estimate, and that calculates out to be, okay, so one way to do this is for us to just think quickly about the range. We've looked at the range above, and we know it's in the range 50 to 100. We know at the bottom of the range that we had 360 students, travellers, and at the top we've got 760 travellers, and we want to find where the 600th traveller is going to be. Well, we can see therefore this range is that's 400, and where we need to get to is from the bottom. We need to get up to the 600th, 360. So that's our 600, and we know 360 had already gone by the 50, so we know we need to add 240. And if we want to do a linear approximation here, we can see that we're starting at 50 miles, and then we're interested in linearly 240 out of the 400. That gives us our proportion of the distance across from 50 to 100, doesn't it? And then multiply it by 50, because that's the distance, the 50 miles. And if we calculate that out, we'll have 80 miles. Okay, so yeah, 80 miles. The alternate here is to draw yourself very quickly a section of a cumulative frequency diagram. So we've got our 50 miles, and at 50 miles we've got 360. If we did our scale, that would be 360. And at 100 miles we have 760 individuals. So there we are. We can draw a straight line between them because that's what we do in cumulative frequency. It's effectively a linear approximation. Then we go, actually we want to find our 600th, so 600 on our scale. We dot across till we hit the line, dot down, and we get 80 miles. So that's another way of getting 80 miles. So that's that one. Okay, that was 3 marks for finding the 80 miles. As ever, here's my quick summary on histograms. So we're graphing a scale variable on our x-axis, whatever it is. In this case, it was miles, and on our y-axis, frequency density. So we're taking our frequency and we're dividing it by the width of the class. Make sure that your graph is continuous, in that you haven't left gaps. This isn't a bar chart, so you're going from 0 to 60 in this case, say, in miles, and you've labeled it as miles, and everything's drawn to scale in that direction. Similarly, on the vertical, make sure your scale is set and everything is drawn to scale in the vertical, and make sure you've labeled it frequency density, and you should put like travelers per mile, whatever it is. That's what it was here. So make sure it's fully labeled. You will get marks for fully labeling it. If you need to estimate from the in the question, either median, they might ask you to find the upper or lower quartile, then you can do a linear approximation about how far along each of these bars you are. The alternative is to draw yourself a mini cumulative frequency diagram. Hope that helps, and best of luck.